So what are silicates? Silicates are of great importance, which constitutes 90% of earth crust. It constitutes 90% of earth's crust. Remember, okay? Silicates are any mineral having any rock having silica or silicon dioxide in it. Okay, silicon oxide in it. So basic unit in all silicon minerals are silicon oxygen tetrahedra. So this is a silicon oxygen tetrahedra where four oxygen atoms are binded with one silicon atom at the center. How this looks like? It will look like this. This is a three-dimensional figure. This is the center. This is the oxygen that is in the back part of the tetrahedra. Okay, this is the front part. This is how it is, and this will be connected to the with bonds to the central silica. This is silica, this is oxygen, 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 oxygen. So this is a silicon tetrahedra. Silicon tetrahedra. This is how it looks like. Silicon tetrahedra with the formula Si 4 plus 2 minus 4 because 4 oxygens are there. Or sorry, 4 oxygens are there, right? So you can write it as this is the oxidation state. If you are not from a science background, don't bother about this. But for science students who have done or engineering students, this is the oxidation state plus 4 minus 2. I think you know this. Then SiO4 minus 4. Okay. Okay. Now, so this silicates constitutes all the major minerals. Okay. Now the silicates is classified on the basis of their structure. On the basis of the structure type, this is classified, and we have different examples also. Okay. So first is, remember, Nesosilicates. So we have different silicates. Okay, like this, different silicates are there. We'll go one by one. The first is Nesosilicates. That is means island silicates. So in island silicates, you will have only one tetrahedra, only one tetrahedra, or you can not only one tetrahedra. It will be like all the tetrahedra will not be linked to one another. All the tetrahedra will be isolated. Okay, all the tetrahedras in the mineral will be isolated tetrahedra. That means that are not linked with each other. So the basic structure unit will be like this only, that I have just drawn. SiO4 minus 4. So none of the four oxygen is shared. Zero oxygen sharing with other tetrahedron. So no oxygen is shared with another tetrahedra or another element. All are kept to the Si only. Okay. So isolated tetrahedra are bounded to have one another via ionic bonds with interstitial cations Mg2 plus Fe2 plus Ca Mn etc. Okay, it can have interstitial cations to dissolve the valency here. That is minus 4. Then there is dense atomic packing, high specific gravity, high hardness, poor cleavage, equidimensional crystal habit. Because it is a just isolated tetrahedra, it will have poor cleavage, high hardness, and high specific gravity. And these are the elements that are present in the interstitial spaces to make up the valency, but not shared with the oxygen. Oxygen atoms are not shared with any other tetrahedra or any other elements. Okay. Now, groups are simple group. You can just memorize that this is olivine or garnet. Olivine or garnet is an example of a nesosilicate or island silicate. Remember, neso comes from nest. Nest means a tree. I mean a bird nest on a tree. Okay, so nesosilicate you will remember, and nest just lies in a as a single part. So you will remember nesosilicates are also single. Okay, they don't have paired structure. Also, you can say island silicates. Okay, island silicates means single island or a single nest or nesosilicate. Example is olivine garnet. Okay, okay. Next is sorosilicate. Sorosilicate. Remember, sorrow comes from sorrow. Sorrow means double silicate. Two terms are there. Sorrow, so double silicates, double island silicates. So it will be one oxygen atoms. One oxygen will be shared. Only one oxygen ion will be shared. Okay, one of four oxygen. See, one of four oxygen is shared. So the ratio is 2:7. 2 is to 7. 1 2 3 4 5. 1 2 3 4 5 6 7. Okay, 2 silicon with 7 oxygens are present. So 1 is 2 to 7. This is very important to write in exam. Ratios. Previous one was 1 is to 4. Right? Island silicate. 1 is to 4. Sorosilicate. Sorrow double. Sorosilicates are 2 is to 7. Two-leaf tetrahedra isolated from all other tetrahedra. Then hemimorphite. This is the hemimorphite is a very rare mineral to have in nature, but this is how it is. Hemimorphite is an example of sorosilicate. Then coming to cyclosilicate, as the name resembles, cyclo means ring structure, ring. Cyclosilicates. So 2 out of 4 oxygens are shared. 2 out of 4 oxygens are shared. So here it is shared, here it is shared. Again here and here shared, here and here shared. So 2 out of 4 oxygens are shared. The ratio is 1 is to 7. Ratio is 1 is to 7. 1 is to 3. 1 is to 3. Okay. Tetrahedra linked and arranged in ring form. Ring may contain group of 3, 4, 5, 6 linked tetrahedra, extremely strong minerals. So beryl and tourmaline. You will remember this as beryl and tourmaline have a prismatic shape. Okay. Beryl and tourmaline have a prismatic shape and looks like this. And looks like this. This is how a prismatic shape looks like. Okay. So this structure actually is the sort of the beryl structure and tourmaline structure in internet, and you will be able to understand. See, you will be seeing you will be seeing prismatic shape. This is a prismatic shape. Tourmaline have they have what? They have prismatic shape. Prismatic shape. And is an example of cyclosilicates. Okay. Cyclosilicates. Then next is ionosilicate. Remember iono. Iono means iron. Iron means iron chain. Okay. Iron means iron chain. Ionosilicates or single chain silicates. So single chain will be there. Ionosilicates. Remember, iono means comes from iron, and iron have chains. So single chain silicates. Ratio is SiO is 1 is to 3. Again same. Okay. 1 is to 3. Tetrahedra linked to form straight chains. So 2 out of 4 oxygens are shared. Same like I have cyclosilicates. An example is pyroxene. Pyroxene is a chain silicate. Okay. And this does double copy, that is double chain silicate. Again, ironosilicate only, but double chain. Okay. So 2 or 3 or 4 of 4 oxygen is shared. So 4 is to 11. Here you can see the ratio is changed. 4 is to 11. So out of 11 oxygens, 4 is shared. Okay, that means 4 is to 11. Tetrahedra linked to form straight chains. Half tetrahedra shares 3 oxygen, others may share 2. Okay. Excellent example is amphibole. Amphibole is example of double chain ironosilicate. Then the second last, that is phyllosilicate. Phyllosilicate is a sheet type silicate. Phyllosilicate is a sheet type silicate. Phyllosilicate. Remember, phyllo means फैला हुआ. फैला हुआ means sheet, like a sheet. फैला हुआ. फैला हुआ silicate, like a sheet silicate. Okay. Remember, phyllosilicates आप ऐसे याद रखेंगे कि वो फैला हुआ है. That means it is a sheet silicate. Okay. So brilliant example of sheet silicate is mica. You know, mica, you will be able to remember mica. Example of sheet silicate or phyllosilicate. So 3 out of 4 oxygen, that is SiO, will be 2 is to 5. Okay, remember this ratio always. Forms sheet structure in which there is continuous linking of hexagonal group of silica tetrahedron. So it will be platy and flaky habit. As it is a fella hua silicate, it will have a platy and flaky habit. Prominent cleavage will be there. Very soft, big and very brittle. Okay, low specific gravity, flexible, and atomic bonds between two sheets are weak. Because it is a sheet type, so atomic bonds are very weak, it can be teared apart. Okay, so mica have very low atomic bond. You can tear mica mineral from your hand only. Okay, if you are given a mica sheet, you can just tear it like a paper. So it is very soft mica. Okay, but last is tectosilicate. Remember, tectosilicate is a complete framework of silicate. Okay, 3D structure like quartz. Quartz is very hard, a complete 3D structure. Quartz feldspar. So SiO2 will be simple 1 is to 2. Okay, all oxygens are shared. All oxygens will be shared to one another 1 is to 2. Tetrahedrons are linked in 3D network, strong bonded structure, uniform properties throughout. If some Si4 plus are replaced by Al3 plus, it produces charge imbalance and allows other ions to bond within the framework structure. Thus, feldspars are formed. So, feldspars are found when Al is replaced. Some of the Al replaces some of the Si, and that results in the formation of feldspar.